Hey, welcome everybody. This is the tutorial for time value of money calculations I wanted to spend a little bit of time with. What I have on the screen here is a partial table. You guys have these tables in the back of your book. They're the full tables that run from year 1, I think it's through year 50. And they'll have interest rates anywhere from 1 up to 20% or so. You can find these tables all over the internet as well, and you can also use Excel spreadsheets or financial calculators to do this. But I wanted to show you using the tables in the book how easy it is to actually do some time value of money calculations. So a couple of things before we spend time with the table that we actually have to focus on, and that is there's 3 questions that you have to ask yourself when you're doing these time value of money calculations. And the first one is actually really 2 questions, and the third one will kind of present itself once you get the answers, and that will identify, okay, which table do I use then? So the first question is the money that's changing hands. Sometimes we'll be investing some money, sometimes we'll be paying, sometimes people will be giving us money. We have to determine whether or not we know what the value is of that now, or we know what it is in the future, because the answer to that question will tell us whether we need to use the future value tables or the present value tables. You use the table for whichever number you're looking for. So if I'm looking for a number 10 years from now, I have a current number today. I have an amount of money today that I'm starting with or that we're given in a problem. But we want to know what something is going to be 10 years from now. That's a future number. So once we've got the answer to that question, we've already eliminated 2 of the 4 possible tables to use. In this particular example, we would use the future value table. The present value table would be used when we know what an amount of money is in the future. Let's say we need $10,000 to buy something at some point in the future. We want to know how much do we need to put aside today, or in a number of payments starting today, that will allow us to reach that particular total amount of money that we know we need in the future. In that case, again, we've narrowed down and eliminated 2 of the tables, and we're going to use present value tables at that particular point because present value is what we're looking for. So let's take a look at the tables that we have here. This top table, table A, is the future value of $1. I call this the future value of a lump sum. A lump sum, or a single amount of money, just means whatever dollars we're talking about, whether now or in the future, is one chunk of money. It's only going to happen one time. So this is not a series of payments or anything like that. If we had a situation in which we were looking for future value of a lump sum, we would use table A. So an example of that would be, let's say that we had $5,000 right now and we wanted to do something with it. Maybe we wanted to invest it, or we wanted to buy something. And whatever this item is that we're going to spend the money on, it's going to earn us a particular rate of return, sometimes called the discount rate, sometimes called the interest rate, but it's a rate of return. And so in this particular example, the rate of return that we're going to get is 8%, and the amount of time that this money is going to be at work earning that 8%, let's say, is 10 years. So all you need to do is to determine by kind of coming up with following these 2 points, 10 years and 8%, and you find where those 2 items intersect. And in this case, it's 2.159. That is known as your factor. All we need to do is to take that factor and multiply it by our lump sum of money. So in this case, our factor is 2.159. Multiplied by 5,000. I told us that was the amount of money that we were starting with. $10,795. Okay? $10,975. Okay, so what this means is if I had $5,000, I invest it for 10 years and I can earn 8%, I will make $10,795. That's what that money will grow to. The second table here, this table B, future value of an annuity, or a series of annual payments or deposits. In this particular case, what we're talking about is a certain amount of money that happens more than once. It's an annuity, means annual. So a series of annual payments. So this means at least once a year, somebody's going to spend an amount of money or invest an amount of money. So if we take our same situation, that $5,000 not only is going to go now, but it's going to go every year. And let's say we're talking about a 6-year time period that this $5,000 is going to happen, and it's going to be a 7% item. So 7% is what we have a chance to earn on all of those individual deposits. Again, you find the intersection of the years and the percents comes to 7.153. So again, we find our calculator, 7.153 times 5,000, because that was the amount of each one of the payments, 35,765. That's the answer to what is the future value of a series of $5,000 payments for 6 years at a rate of 7%. Okay. Series C, the table C and the table D, have to do with present value. So again, in this case, what we're looking for is what's the amount of money that we're concerned with now. We need to start with now. That will grow to what we know already in the future. But in order to get to that amount, we have to use these tables down here. And basically, they work the same way. So we said that first question was to determine whether or not it's present value or future value. The second question is, are we talking about a lump sum, or are we talking about a series of payments? A lump sum, just one shot on the money. A series of payments is at least an annual period of payments going forward for whatever length of time they're giving to you in the problem. So we would use table C when we know about a particular amount of money. Let's say we need $50,000. And we would like that 6 years from now. So what we're asking is, how much do I need to invest now? And our percentage, let's say, is 7%. Again, we find our intersection. Oops, I'm sorry, I'm on the wrong table. Table C, we're talking about present value. $50,000 is the amount of money that we want to have at the end, and we want to have this 5 years from now. And we can earn 5% in this time that we're putting the money aside today, and in 5 years we want it to be worth $50,000. So if we take our calculator again, our factor is 0.784. Clear. 0.784, and we're going to multiply this by the amount of money that we know we need in the future, which is $50,000. $39,200 is the present value of that amount of money. So what that means is if we invest $39,200 for 5 years at 5%, we will have $50,000 when we're done. This last table, present value of an annuity, again, it's that series of payments. So this would work the same way. It's based on the number of payments. In this case, we're looking at 9 years of payments, whatever these payments may happen to be, say $500 a year for 9 years, 8%. Here's our factor. You just multiply that out and come up with your answer. So again, question one, we want to determine whether or not we're talking about money that we don't know is either in the future or it's now, present value. And normally there's a couple of things. There's an amount of money, whether it's a lump sum or a payment. There's a future value, there's a present value, there's an interest rate, and there's an amount of time, okay, usually in years. Just so you're aware, you can also have situations which aren't annual. You could get semi-annual payments, quarterly payments, monthly payments. If we had a 2-year time period, but it was quarterly payments, how many quarters are there in a year? Well, there's 4, so there's 8 quarters in 2 years. So if we had a situation where we were talking about 2 years of quarterly payments, you'd have to use 8 years. You'd take number of years, multiply it by the number of times of compounding, in this case, number of payments, which is 4 in a quarterly situation, 4 per year, times 2, that's how you get 8. And so you would use 8 in the particular percentage, and you'd use that factor instead of the annual factor. So you have to adjust that. Also, you'd have to adjust the percentage. So if we took and divided or multiplied the number of years by the number of compounded periods, 2 times 4 would give us 8 years. But if our percentage, let's say, was 8%, we would have to divide our percent by the number of periods of time, which in this case would be our quarterly types of payments, right? We said our 4 a year, so we would divide our 8 by 4 to get 2%. So if we were looking at a quarterly situation, you'd have to make sure you made those adjustments. We will work on that in the next chapter, but I did also want to point that out. So again, our first question, future value or present value. The second question is, are we talking about a lump sum of money or are we talking about annual payments? And once we identify those two questions, the third question becomes, okay, so which table do we use? Well, if you're using a future value, if what you're needing is a future value of one payment today, that would be future value of a lump sum. If you know an amount of money in the future that you need, but you're trying to determine what amount of money do I need to start with now in order to get to that amount, that would be a present value of that lump sum. B and D, you're only going to use if you have a series of payments. If there's more than one payment, automatically table A and table C are out of the equation. Then you just have to determine, is it a future value of an annuity or a present value of annuity, and then use the appropriate table. Hopefully this has been helpful. Please ask us questions on the discussion board. Watch this as many times as you can. I know I presented a lot of information relatively quickly here, but wanted to try to give you some visual help to go along with what's in the textbook. Thanks.